Adding radical expressions. Okay, first we need a common denominator to put these together. And as we said before, let's say we had 6 and 9, and we're looking for the least common denominator for a fraction. We'll go through the 6 timetables: 6, 12, 18, let's say 24. Then the 9 timetables will be 9, 18, 27, 36. And see here, these have in common, and these are the least that they have in common, and we'll use these as the denominators. Same thing with x and x to the third power. The multiples for x will be x squared, x to the third times another x, which is x to the fourth. Here, x to the third, x to the fourth, x to the fifth, x to the sixth. You multiply each of these by x. And what's common will be x to the third. So in actuality, we're looking for basically the highest power of the two exponentials. Even if we have binomials, and you started writing here the multiples here. So times another x minus 7, equals to the third, and already we have a match here without going any further on both. So let's work with this first one here. We have 4x to the fourth, x plus 3 to the second power, plus 1 over x squared, x plus 3, all to the third power. Okay, now using that idea that we'll use the highest power to be the LCD, so we have x to the fourth, and we have x squared. When we know we go x to the third, x to the fourth, here x to the fifth, x to the sixth, that the fourth will be the highest. We'll just use that here, x to the fourth, x to the fourth, with the 4 here and the 1 here in front. And then we have x plus 3 to the second power, x plus 3 to the third power. I'll say that the both through the, let's say, the timetables, they'll both have the x plus 3 to the third. Okay, now let's see the difference between the numerator and denominators. X to the fourth, x to the fourth. 2 of the x plus 3's, 3 of the x plus 3. So there's an extra x plus 3 in the denominator between here and here. So we'll put an extra x plus 3, just one extra in the numerator. I have x squares down here, and I have x to the fourth down here. So there's 2 extra x4s in this denominator than that denominator. So we'll put 2 extra x squares there. The x plus 3's, we have 3 of them there, and we have 3 of them there. So that's everything. All right, let's write one denominator, x to the fourth, x plus 3, and to the third power. Now, this 4 can be distributed because that's a first power. If it was any other power, second power, third power, whatever power, we could not distribute the 4. But because it's a first power, we can distribute the 4. So 4 times x gives us 4x, and 4 times 3 gives us plus 12. And then the plus here, and then that's 1x squared. And we're finished. Now, some people require that this be placed in order where the x squared is first, then the 4x, and the 12. But for our purposes, we can stop here. Next, we have the 3 here, the 2 here, x to the third, and x minus 5 here. And we have 5 of those. And we got x minus 5 here. We got 6 of those. Okay, let's find out what we have. So 3, 2, x and x to the third. So x to the third will be the LCD. So let's put an x to the third in both places. We have x minus 5 here, 5 of those. And we have 6 of them here, so we use the 6 for the LCD. x minus 6 to the 6. Sorry, x minus 5 to the 6. X minus 5 here to the 6. And let's see how we've increased. So we went from 1x here to 3x's, so that's an additional 2x's. So let's put x squared there. We went from 5 of these x minus 5s to 6 of them, so that's an extra. That's 1 extra. We went from x to the third to x to the third, so no extra x's there. 6 of these x minus 5 to 6x minus, so there's no extras there. So let's put everything together. So x cubed, x minus 5 to 6. So this is to the first power, so the 3 and the x squared can be distributed. So 3x squared times the x gives us 3x to the third power. And 3x squared times the negative 5 gives us negative 15x to the second power. Then plus, and then the 2. And it is in order, which is great. Okay, next. We have these two expressions, and we have a 2, a 1, and let's see here. We can go ahead and start finding the common. Well, no, I'll just write the problem out. So you gotta see what we're dealing with. 4th, x to the 4th, x plus 2, third. Okay, now if x and x to the 4th, we'll use x to the 4th for the least common denominator. We have 4 of these x plus 2s, and 3 of them, so we'll use the x to the 4th. X plus 2 to the 4th power, should I say. Okay, now let's find out what's extra. Here we have 1x, here we have 3 x's. That's 4 x's, should I say. And so there must have been 3 x's that have been introduced. So let's introduce 3 x's here. There's 4 of the x plus 2's there, 4 of the x plus 2 there, so no extras. I have 4 x's there, 4 x's there, that's fine. But I have 3 of these x plus 2's and 4 of the x plus 2 down there. So there's an extra x plus 2 here. So let's put an extra x plus 2 there. Put 1 there. Okay, now let's put everything together. Everything over x plus 4, down x to the 4th, then x plus 2 to the 4th power. So 2x cubed, we're going to write that, 2x cubed, the plus sign. And then we're going to multiply the 1 times the x, that'll give us our 1x. And then 1 times the 1, that'll give us 1. And nice, it's in order. Good, done.